So we have looked at data, information, metadata, data warehousing architecture, and so we have looked at different components of data warehouse, namely OLTP, ETL, staging area, OLAP or data warehouse, and BI. So we also looked at differences between OLAP and OLTP. So we looked at Tableau's VisQL, which is a visual query language. So we have looked into that as VisQL as a combination of SQL and DL, which is descriptive language. So we also looked at some properties and characteristics of Tableau, so which differentiate it from other BI tools. So next generation BI tools. So we have looked at so the characteristics are advanced visual analytics, fast performance, so connecting to any data, so integrating with the businesses, be it any domain, and web and mobile authoring capability. So these are the feature properties or characteristics of Tableau, so which we have discussed. So also we have looked into Tableau components. So the Tableau components or Tableau ecosystem, which is containing 8 different components. So which are Tableau desktop, Tableau server, Tableau reader, Tableau public, Tableau online, Tableau mobile, visible, and Tableau prep. So these are the components that we have looked into with the demo, and we also looked into various versions of Tableau. So, and we have looked into the Tableau desktop installation and what are the prerequisites of Tableau desktop installation. So what are the operating systems prerequisites, and RAM, processor, hard disk, and which are the different editions that are available. So we have looked at what are the options, like the trial period being 14 days if you download the application, desktop application. And we also looked into an option to get the license, a student license for 1 year. And we also looked at what is a Tableau repository, so where all the data would be stored, all the data sources would be stored, and all the logs will be stored. So these are the things that we have discussed yesterday. So we have just started on data connections in Tableau. So we have looked at how we can connect to a live connection and a extract or a hyper connection. So um, within extract, I mean, we have also seen that we can connect extract as all data or extract as some data. So we will look into in detail today about this data connections in Tableau. So yesterday I've asked you to download Tableau desktop application. So I believe everybody have done that. So have you done that? Have you did you download all, everybody? I mean, have you downloaded the desktop
Not yet,
application?
Kranti. I'm still downloading it.
Yes,
Downloading it.
yes, I downloaded.
Okay, please download it as soon as possible. Then we'll start working on it. Okay.
Yeah. Okay.
Thank you. Right. Right. So you can also download Tableau Public and Tableau Reader along with those. So those are free versions. You can also play around with Tableau Mobile also, which is a free applications. Right. So today, so we'll start with live connection. So right. So what is a live connection? In live connection, Tableau creates a live communication path between uh, data source. That so in live connection, uh, Tableau creates a a live communication path between the data source and Tableau. So a live communication path means whenever the modifications or data changes are made in the data source level, so they will be automatically reflected into Tableau when we refresh the connection. So what I mean is, in a live connection, so a live communication path is established between the data source and the Tableau. So whenever some modifications in the data source or some data changes are made in the data source level, so they will be automatically reflected into Tableau with a refresh of the connection. Okay. So basically a live communication path will be established between data source and Tableau in live connection. So, so now we'll try to create a live connection. So we have to go to this icon to create another connection. So we'll choose Superstore sales as our data source. So in order tables is the table that we are using. So now, so we are selecting a live connection here. Or what we can do is we'll take a simple data rather than a huge data set like this. So I'll create one more sheet. I'll close this. I'll create one more connection. So basically before that I'll try to create a file. So I'll create so there is a text file, so like this. So basically, so I'll create a text file using Notepad with this data. Okay, so basically it's a data of stores and sales. So there are different stores. Okay, there are different stores uh, and the sales of different stores here. So it's a simple data file, and we'll save this on we'll save this onto our desktop. Now, so we'll open a desktop, Tableau desktop, and now um, we'll try to create a connection. So we'll click on the text file. We'll select the text file in connection and click on the text file which is located at the desktop location. We'll select the text file and click on open. Right. So the connection type here is live. The connection type here is live connection. We'll select the connection type as live and enter the connection name as live. Just a second. Right. So we'll name the connection name as live. So this is the connection name. So we'll name this connection name as live, and click on the sheet or worksheet here. Okay. So we'll click on view data. So there is an icon here called view data. So we'll click on this. So it is coming from a live connection. Okay. So the data is having Asda, Target, and Walmart with sales 300, 700, and 1000. Right. So this is the data. So we'll add a new line of data to the text file and save it. We have added a new line to the data sheet text file and then saved it. So we'll click on view data again in the live connection, and we are seeing that the data is not updated yet. There are only 3 stores here. So now we'll right click on the live connection. We'll right click on the live connection and then click on refresh. Then click on refresh. Now we will click on the view data and see that the data is updated now with a new line added to it, right? So basically what is happening here is, so a live communication path is established between the data source and Tableau. So the live communication path means whenever the modifications or data changes are made in the data source level, so it will be automatically reflected into Tableau with a refresh, with a with a refresh, the data would be automatically reflected into Tableau with a refresh of the live connection. Okay, so this is about live connection. So now we will we'll look into uh, extract connection. Okay, so there is one more option. Uh, so the one more option to connect the data called extract. Okay, so we'll look into extract connection. So what is extract connection? So extracts are saved subsets of a data source. So extracts are the saved subsets of a data source that you can use to improve performance. So you can use an extract to improve performance, and they are the saved subsets of a data source. So you can also use this for upgrading your data to allow for more advanced capabilities. So you can also upgrade your data using an extract for more advanced capabilities. We look into what are those advanced capabilities. So we can use this extract also to analyze our data in an offline mode. So live connection has to be connected to the data source. However, extract can actually can be worked offline. So a connection need not be established with the data source if you use a extract. So you can create an extract by defining filters and limits that include the data you want in the extract. So you can actually you can define some filters and limit the data that you want to be shown in the extract. Okay, so you can also limit the data that you want by adding some filters into the extract. So after you create an extract, you can refresh it with the data from the original data source. So once the extract is created, so um, you can refresh it with the uh, data from the original data source. So when you refresh an extract, whenever you refresh an extract, so that extract can be refreshed with the data from the original data source as well. However, in the live connection, whenever you open a worksheet having a live connection, all those times, whenever you open a file with live connection, each and every time the data would be picked up from the data source. However, if you only refresh the data in an extract uh, at a particular time, then only the extract data would be uh, updated with the original data in the original data source. So there are two options to refresh the data using an extract. So you can extract the contents of the data with a full refresh, or you can also extract the data in an incremental way. So in a full refresh, all the data gets replaced. In an incremental refresh, uh, uh, only new rows gets added to the extract. Okay, so there are two options to uh, do the extract. Okay, so there are incremental refresh and full refresh. If you select all rows, it will take all full refresh. If you select incremental refresh, so it will add only new rows which have got added after the last refresh. So this incremental refresh will only add rows that are new since the last refresh, right? So you may ask a simple question, um, what why are the extracts valuable? So you may ask the question like, why are extracts valuable here? So extracts are valuable because they provide a local copy of the data to make the workbook portable. So extracts actually provide a local copy of the data to make the workbook. This is a workbook, right? So Tableau workbook. This is a Tableau workbook which is having a extract connection. So if you use an extract, it will provide a local copy of the data to make the workbook portable because you are working offline with an extract. So the other usage is to limit the access to the source database. So by using an extract, you can limit the access to the source database. So there are multiple scenarios where you want to limit the access to the source database. So you may want to limit the access to the source database for for reasons like security reasons. So you don't want to uh, compromise security to access database regularly. So in those cases, you use an extract. So there might be some administrative reasons also, some hierarchical reasons like only few people are allowed to access the database. So in those cases also, you create a subset of the data and then use the extract rather than connecting directly to the data source using an extract. So there might be few other reason also like load reasons. So when you connect to the data source with a live connection, so there might be some load reasons. So if the database is complex and very large in size, so connecting to the database will also have some loading issues. So to forego those issues, so you use an extract for load reasons as well. Okay. So you may an extract can also be valuable in cases where they provide performance improvements over direct database access. So basically, um, all these aspects discussed now uh, uh, actually drill down to improving the performance of the connection, right? So using an extract will provide a performance improvement over direct database access, right? So that's why extracts are valuable. uh, there might there might be one more reason. So some functionalities in Tableau may not be available from a live connection to your database, but they are available from an extract. So for example, if you connect a Excel data source, so distinct count or median from Excel cannot be sourced from a live connection. You can get it only from an extract. So that could be also one of the reasons. So you may also ask me, so when will you want to avoid extracts? So these are all the different valuable reasons why you want to use an extract, but there are also some cases where you don't want to use an extract. So the one reason is when you want to control where the data resides. So when you create an extract, it is actually stored locally in your desktop, right? So if you want to control where the data resides, you don't want to create an extract. Also, uh, one more reason is when you want all the queries against a source system from the freshest data. So that means if you want a real-time data, you don't want to use an extract. So in those cases, we want to use a live connection. So the second reason is when you want all the queries against the source system for the freshest data. So that means you want a real-time data. So then you will be using a live connection rather than a extract connection. Okay. Right. So what are the options for extracting data? So when you go to extract, so there are different options here. So there are filters. Okay. Filters here in filters, data can be pared down so that the extract will only contain necessary field members. So that means you can add filters so that you can actually filter down the data set into the only the required number of field members. You can add you can add filters, and then you can pare down the extract. So we also have aggregation here. So aggregation is nothing but, so whenever you want to extract any data source, so it actually should fit into the local system. So that means if the data source is large and complex, even the extract will also be huge, right? So in those cases, so the extract should also fit into the memory requirement of the local system. So in those cases, if you use aggregation, some part, at least you can actually reduce the size of the extract to at least 20%. So using aggregations, what we do is you summarize the data based on the visual dimensions. So you using aggregate, if you choose aggregate data for visual dimensions, so you, for example, um, if the data is in dates, so if the data in our data source, for example, I'll show you a data. So this is the order date, right? So this is in the form of individual date. So by aggregating this data, you can aggregate on a month level or a year level. So what happens is, so this is January of 2010. So this is also January of 2010. If you aggregate on a month level, so these two rows will get combined into a single row. If you aggregate on a year level, all the 2010 data gets added into a single row. So doing so, what happens is, so the size of the extract gets reduced. Okay, the size of the extract gets reduced. So that is about aggregation. So we also have incremental refresh here. So what is incremental refresh? So all the new, if you refresh a data, all the new rows after the last refresh gets added to the extract. So it is great for transactional data. So an incremental refresh is great for transactional data. So extracts can be refreshed incrementally based on the date or time field. So you have to create an incremental key. So from the database, so connect to a database like, for example, so go to another data connection where you have, right. So here you have a increment. If you want to do an incremental refresh, select a date field. Select a date field. Okay, so extracts can be refreshed incrementally based on the date or time field. So after the last refresh, whatever are the new dates added, so only those rows gets added to the new extract. So if you don't use incremental refresh, all the rows will get replaced into the new extract. So you can also limit the number or percentage of rows. So if you want to limit number of rows or percentage of rows in the extract, that means if you want top 10% of the rows, or of top 1,000 rows in the database, so you can define that as well. So basically you can limit the number or percentage of rows. So what this does is it ensures that data is less than a certain size. If you don't want to actually see complete data, so you can see a portion of the data by using an extract or limiting by number or percentage of rows like this. So there is another option called hide all unused fields. So this will automatically hide any fields in the data window that were not used in the Tableau workbook. So this will, by clicking on this option, so this will automatically hide any fields in the data window that were not used in the Tableau workbook. So while creating a workbook, if you don't use any fields, so those will be not included in the extract. So hidden fields do not get included in the extract, thus retaining only the necessary fields to power the visualization. So basically what happens is only uh, the fields used in the visualization are used. Hidden fields do not get included in the extract, and eventually that actually powers the visualization, that improves the performance of the visualization, like that. Okay. So so we, if you see the connection extract connection mechanism, so it works like this. Okay. Extract connection mechanism will be like this. So there will be a data source and Tableau data engine and uh, .tde or hyper files, and then Tableau. So what happens here is in a extract connection. So in the extract connection, Tableau will connect to the data source. Okay, Tableau will connect to the data source, and it takes the snapshot. So it takes the snapshot of the data source. Okay. So once the Tableau connects to the data source, it takes the snapshot of the data source, and it places that snapshot into a powerful component known as Tableau data engine or hyper analytical database engine. So it is called as hyper analytical database engine from Tableau version 10.5. Okay, before that it used to be called as Tableau data engine. Okay, so basically Tableau connects to the data source, and it takes the snapshot of the data, and it places that snapshot into a powerful component known as Tableau data engine or hyper analytical database engine. So Tableau data engine or hyper engine reads the data from snapshot. So once it places the snapshot into this component, so this Tableau data engine or hyper engine reads the data from the snapshot. It reads the data from the snapshot, and it will write the data into a new file known as the Tableau data extract. So it reads the data from the snapshot and writes the data uh, into a file, into a extract file known as .tde or .hyper. Okay, so it writes the data into a new file known as Tableau data extract, represented by .tde in older versions, and .hyper in new versions of Tableau. Okay, this is a Tableau data extract file. So every time Tableau connects to the .tde file or .hyper file in the same machine, rather than connecting to the actual data source. Okay, so by creating a extract connection, what happens is, this is a mechanism of an extract connection. In live connection, Tableau establishes a live communication path with the data source. In an extract connection, Tableau connects to the data source and creates a snapshot of it, and then stores that snapshot into Tableau data engine or hyper engine, and hyper engine in turn um, reads the data from the snapshot, and and it will write that data into a new file called as Tableau data extract. It is represented by .tde or .hyper file. So every time that from the next time Tableau, if it wants to connect to the data, it connects to the .hyper file rather than to the data source. Okay. So you have to note here that in extract connection, as Tableau is accessing .td or .hyper file, it is possible to connect in the online as well as offline mode. So because it's not connecting directly to the data source, you can work online or offline mode using an extract connection. So in a live connection, it is possible only to work in a online mode. So you have to be connected to the data source to work in a live connection. So if you are not connected to online, so because a connection path will not be established with the data source if you are not connected online, so you cannot work in with Tableau. However, in an extract mode, you can either work on online or offline mode using an extract. Okay, so from Tableau 10.5 version, Hyper Data Engine. So see, from Tableau 10.5 version, it is called as Hyper Data Engine. So it is a new feature from 10.5, which is having in-memory functionality. So this Hyper Data Engine is having in-memory functionality. Okay, so we have to note here that while creating extracts, dot hyper file or hyper extract is much faster in generating extract files than the existing .tde files. Okay, um, dot hyper file. So from 10.5 versions, if you extract any file, you will get a dot hyper extension file only. So this is much faster compared to the older .tde files. So while working with any complex or large data sets. Okay, so the extract will be saved in what format? Dot hyper format. Okay, so if you want to understand what is Tableau data engine or hyper analytical database in detail, so it is what is it? It is a high performance analytical database in our machine. So it is a Tableau data engine or hyper analytical database is the high performance analytical database in our engine, in our machine itself, local machine, which is having a in-memory functionality. So which is, it is having a in-memory functionality. So what is in-memory functionality? So in-memory functionality means it will make use of the primary memory. That means it makes use of RAM memory at the time of performing the operations. So at the time of performing the operations, it makes use of primary memory, which is the RAM memory. And after completion of the operation, it will store the output file in the secondary memory or disk space. So while performing the operation or when you're connecting to the database and stuff and you're performing the different extraction and so it will perform all the operations, it will using primary memory or RAM memory. So after the operations are completed, so it will save the output file in secondary memory or disk space. Okay, so we'll look at an example here as well using extract connection. So we'll go to the data, we'll go to the file, right? So we'll click on connect to, we'll click on, so this is a icon to click on new data source. Okay, we'll click on connect to the new data source and select the text file. So we'll select the sales file which we have created in the previous example, and we'll click on open. So we'll select the connection type as extract. Now we are seeing an extract connection here. Okay, so before that we'll remove this, then save it. Right. So we have selected the connection type as extract, and we'll enter the connection name as extract. So we'll keep the connection name as extract. Right. And we'll click on the sheet. So after clicking the sheet, it automatically creates a dot hyper file. As you can see here, extract dot hyper file is a pop-up window that appears after you click on a sheet. After you select extract and click on a sheet, you'll get a pop-up window to save this .hyper file. Okay, in the data sources folder of Tableau repository. In Tableau repository, there is a folder called data sources. So all that hyper files will be saved in this location. In documents, my Tableau repository, in data sources, this .hyper file will get saved. So it is creating a local copy in our machine, local machine. Okay. So now click on view data. So you are getting 3 stores here. Right. So we'll refresh by getting data changes in the extract connection as well, as we have done in the live connection. So we will add a new line to the data in the previous task file and save the changes. We'll do that again, similar thing again. Then save the file. Now, so we'll click on the view data. So this is an extract file, right? So we'll click on view data. We'll see that the data is not updated yet. So we'll right click on the connection. Close this. We'll right click on the connection. Okay. And select extract here, and then click on refresh. Click on refresh. So note here that when we refresh an extract connection, it will run the complete mechanism again. So that means it will clear the existing content of .hyper file and writes the new data from snapshot. So when you are refreshing any extract, it is taking a snapshot again. So .hyper file is saved in our Tableau repository, right, in data sources folder. So when you're refreshing it, Tableau actually is replacing the existing content in .hyper extension file with the new data from the snapshot. So you're getting a pop-up like this. So when we refresh the extract file every time, it will not create a new .td or .hyper file. It will make use of the existing .hyper file. So it basically replaces the already existing hyperfile. We have created a hyperfile, right, in our previous step. So by refreshing the data in an extract, it replaces the already existing hyperfile. In the warning window, click on yes, because so read what it is saying. The entire contents of the extract will be replaced during the extract refresh. If you have modified filters or hidden fields since the last extract was taken, you might have data that will be lost during the extract refresh. That means it will replace all the content again in the .hyper file. So click on yes here. Okay. So now view the data. So as you can see, a new row has been added after refreshing the data in an extract file, right? So also note that an extract connection will be indicated with this icon, a double cylinder icon with a arrow in it. However, with a live connection, it is indicated with a single cylinder like this. Okay, so this is a live connection icon, and this is a extract connection icon. So now we will see how we can test the size of the hyperfile, .hyperfile. So in this connection, I have used the data source called training superstore sales. So this is the data source that I've used in this connection. I've created an extract of this and then saved it as a .hyper file. Okay, so I'll go to Tableau repository, documents, my Tableau repository, and data sources. Here, this is a file that I've created. This is a .hyper file. So as you can see, the size of the size has been the extract file is comparatively less when you see the actual size. So the extract file size is 1.12 MB. Okay, so just remember this 1.12 MB is the size of extract file. And if you see, if you see the size of the actual data, so it is 5.4 MB. So actually the size, you can see the size of the local copy data being very less compared to the actual data size. Okay, so basically uh, it will be around in some cases, in most of the cases, it will be around 3 to 12% of the original data size. Okay, because when we compare with the actual file size, um, dot hyper file will have it will be the data will be everything in that dot hyper file will be stored in a binary format and in a columnar way. So that is the reason why you will get a lesser size compared to actual original data. Okay, so we can also convert a live connection to extract and extract to live connection. Okay, so to convert a live connection to extract, so this is a live connection, right? If you want to convert a live connection to extract, right click on the connection and click on extract data. Click on extract data and click on extract here. In the extract data window, click on extract and you can save the TD or hyper file and the connection will be changed to extract. And you can see that the live connection has been changed into an extract connection, right? So, so to convert an extract to live, right click on the extract connection. So to convert an extract file into live, right click on the extract connection and uncheck the use extract and uncheck the use extract. So as you can see, an extract connection has been converted into a live connection like this. So when we have to note here that when we convert the extract to live, Tableau just changes the connection type. So the dot hyper file will remain the same. So if you can convert an extract file into a live connection, Tableau just changes the connection type. However, the dot hyper file which has been extracted in the first place will remain the same in the Tableau repository in a data sources folder. We have to note here that the dot hyper files are reusable components. So these dot hyper files in Tableau repository created, these are all reusable components. We can directly connect it to connect to all these hyper files. So you go to connect to data source more, and then you can connect to any data extract or dot hyper files like this, and then you can start building your visualization. Okay, so basically these dot hyper files are reusable components. So you'll see where you will use live connection and where you will use hyper connections or extract connections. So there are two cases where you prefer live connections. So the first one is, so when when you use a live connection, so the first case is if you the data in the data source is changing frequently. So if the data is changing frequently, for example, stock data, so you will use a live connection when the data is changing frequently. The second case is while connecting to high performance databases. So while connecting to high performance databases, you'll use a live connection. So when will you use an extract connection? So you also use an extract connection in two cases. So the first case is while connecting to a low performance databases. So when you connect to a low performance databases, for example, all the files, Excel or Access data sources, you use a extract connection. So while connecting to a low performance data sources like files, Excel and Access, etc. So the second case is if you want to connect to data in an offline mode. So if you want to connect to a data in offline mode, you use a extract connection. So note here that when we connect to files like Excel or text, Tableau gives us slow performance in the live connection. So if you use a live connection for Excel or text files, so Tableau gives slow performance. So don't use live connection for text files or Excel files. So to improve performance, we can use that extract connection by using Tableau data engine. So for all these files or Excel or Access files, so you use extract connection to improve the performance. So live connection is also dependent on data source every time. So a live connection actually depends on the data source every time. However, an uh, extract connection is dependent only while refreshing the data. Okay, so an extract connection will depend only while refreshing the data. Okay, so we'll see some differences also between a live and an extract. So a live connection is in terms of connectivity, it's an online connection. So an extract connection is both online and offline. So in terms of data source dependency, so it is the live connection is dependent on the data source. Live connection is dependent on the data source, while an extract is dependent on the data source only while performing refreshing. So in terms of live connection, so in terms of the dot hyper usage, it is independent of any dot hyper file. So however, in terms of extract connection, it is dependent on the dot hyper file. In terms of refreshing mechanism, we need to refresh the connection in live connection. So in extract, we need to refresh the extract file. So here we are refreshing the live connection. Here we are refreshing the extract file, which is .hyper file. So in terms of refreshing type, um, in live connection, we can only use an incremental refresh. We can only use a incremental refresh in a live connection because all the data would be only new rows would be added to live connection. However, in extract, we can either use a full refresh, which is by default option, and also we can use an incremental refresh. Incremental refresh is also possible in extract. We have seen how we can do full and incremental refresh using an extract also. So in terms of performance, live connection gives less performance when compared with the extract connection. Okay, as live connection is dependent on various external factors like availability of machines, network speed, and also data transfer rates, etc. So it when it depends on the external factors. The live connection depends on the external factors, so the performance is slow, whereas extract connection gives very good performance, as every time Tableau will not connect to the data source, it will connect to the dot hyper file in the same machine. Okay, so it also will not depend on the external factors. So it will result in a better performance. Okay, so in terms of data storage, live connection doesn't store any data. However, in the case of extract connection, it stores the data in the form of dot hyper file in the local machine. So in terms of use cases, live connection is recommended if the data is changing frequently and while connecting to the high performance databases. So an extract connection is recommended if the data is changing very slowly and while connecting to files like Excel, CSV, text, etc., and to improve the performance using Tableau or Hyper Data Engine. Okay, so these are the few of the differences between live and an extract connection. So from Tableau version 10.5, .tde files are not available. From Tableau 10.5, .tde files are not available. Okay, only hyper files are available. Only from 10.5, only hyper files are available. So it is possible to convert .tde to hyper automatically. Okay, if you open a already established, or if you are working in a low, older version, if you have a .tde file, if you open it with the 10.5 version or above versions, so they will automatically get converted into a hyper file. So after converting a .tde file to a hyper file, again it is not possible to convert hyper to TDE. So it's a one-way process. If you convert a .td file into hyper, so you cannot again convert back into .tde. So it's a one-way process where it converts only once. So it upgrades to hyper file, because hyper file gives you much better performance. Okay. So these are the few of the things that I wanted to discuss about live connection and extract connection. So any questions?
Kranti, I have a question.
Right. Tell me.
Yeah, so is Tableau can connect to XML source also? XML
Yes.
file?
Yeah, it can.
Okay. And
Yeah.
one more
So you
thing.
can, yeah, you can actually select this. So while connecting to the data,
Uh-huh.
so you select more, and you can select you can connect to any file.
Okay.
Okay. Yeah. Yeah, we're
And
saying
other
something.
question I have, if what you have shown text file is comma delimited. So if we have the text files pipe delimited or something, still that will still have a connectivity. I mean to say the rows and appearance will be properly. It will be shown in right.
Yeah, so Tableau works with only structured and semi-structured data. So it will not work with unstructured data. Okay.
Okay.
So the
Mhm.
input should be either structured or semi-structured in nature.
Okay.
Okay. Right. So we'll take a couple of minutes break now. So after the break, I mean, we'll discuss dimensions and measures. So we'll discuss about dimensions and measures. Okay. See you after a couple of minutes. So now we are going to look at dimensions and measures. Right. So, so before going into Tableau, we'll look at data warehousing terminology. So in a data warehouse, so the information always gets stored in the form of a master and a transaction table. Okay, so in a data warehouse, the information always gets stored in the form of a master and a transaction table. So I'll try to explain this with a picture. So this is a data warehouse. And in a data warehouse, the information gets stored in the form of a master and a transaction table. So this is a master table. And this is a transaction table. So information in data warehouse stores in the form of master and a transaction table. Right? So within master, there are dimensions and measures, and within transaction table also there are dimensions and measures, but the proportions will vary. So there will be dimensions and measures in master table, and dimensions and measures even in transaction table. And these are measures. Right? So these are within master table. And these are within transaction table. However, in a master table, 99% of the cases, there will be dimensions only. In transaction table, 99% of the cases, there will be measures only. So in master table, the chances of being a measure is only 1%. And in a transaction table, it being a dimension is only 1%. Okay. So what is a master table here? So a master table is a table which contains the information about the business. So in a data warehouse, a master table that is a table which contains the information about the business. It is known as a master table. So for example, uh, if you think that there's a table called products, so the product table contains the business information of a supermarket. Okay, so supermarket is a business, and the products table contains the uh, business information of a supermarket. For example, the business is, if it is a college, so the course table is the information of a college. So similarly, for an organization, employee table is an information about organization, etc. So so these are some of the examples where the master table gives the information about the business. It will act as a master table. Okay, so master table always contain the unique information also. So master table contains always unique information. So to maintain unique information, it always contain a primary key in it. So master table contains a primary key to maintain unique information. So basically, what does a master table contain? It contains a primary key. It also contains non-numeric data. Okay, so basically, it contains all the textual information. All the textual information will be in master table. So also that date also comes into master table. So the date information and the textual information plus the primary key is the content of master table. So what are the contents of the master table? Primary key, non-numeric data, which is textual information plus date information. So that is those are the contents of the master table. So coming to transaction table, the table which contains the metric information is known as a transaction table. So the table which contains the metric information is called a transaction table. So what are metrics? Metrics are nothing but integers, okay, or numbers. Okay, metrics are nothing but integers or numbers which are used to analyze the business. So basically, uh, all the numbers will be in transaction table, which are nothing but metrics or integers. Okay, so these are used to analyze the business, right? So metrics are the measuring points of any business. Metrics of the are the measuring points of any business. So we have to note here that the relationship between the master table and the transaction is that the master always act as the parent. So master table always act as the parent and the transaction table always acts as the child. Okay, because without any business, no transaction will exist. So master will always be as a parent and the transaction will be as a child. Okay, because without business, there will be no transaction existing. Okay, so in transaction, there will be a foreign key plus all the numeric information. All the numeric information plus a foreign key will be the contents in a transaction table. So what are the differences between master and a transaction table? The chances of using a master as a dimension is 99%. Okay. And as a measure is only 1%. Okay. The chances of using a master as a dimension is 99%. Okay. Chances of using a transaction as a measure is 99%. The chance of using a transaction table as a measure is 99%. So basically we can conclude that master is nothing but a dimension. Okay. And transaction is nothing but a measure. Okay. We can conclude that master is dimension and transaction is measure. So what are dimensions? So if you say dimension, what is it? So dimension is a angle in which you analyze the business or see the data. So dimension is an angle in which you analyze the business or see the data. So this will help with the help of a dimension, we can analyze any business in multiple angles. Okay, with the help of a dimension, we can analyze any business in multiple angles. Also, um, what is a dimension? It's a categorical field. So dimension is also a categorical field. So containing textual information. It is a categorical field. So what is a measure? So what is a measure in this case? So based on what metric we want to analyze the business, so we use a measure. Okay, so measure is nothing but a metric that we use to mm, analyze the business. Okay, metric is nothing but a metric. Measure is nothing but a metric we use to analyze a business. So in what form will the metric be? Metric is a quantitative field. It's a numeric field, right? So it's a measure is a quantitative field. It will be always be in numbers. Okay, so a field can be a column in a database. So a dimension and a measure can be both a field. So both are called as fields. Measure and a dimension both are called as fields. So it's a column in a database. However, there are differences between dimensions and measures. Okay, so dimension is a categorical field, measure is a quantitative field. Okay, so um, there are different types of dimensions in data warehouse. There are 9 different types of dimensions available. Okay, there are 9 different types of dimensions. Okay, the first one is slowly changing dimension, or it is called as SCD. It is called as SCD, slowly changing dimension. So what is slowly changing dimension? If the data in the dimension is changing over a period of time, then such kind of a dimension is known as slowly changing dimension. For example, student or an employee. So will the information of a student or an employee change very rapidly? No, right? So the information changes either once in a year or in few years. So if the information of employee, if his or her salary details are there, so will it change rapidly? No, right? So it changes either once in a year or on twice in a year. Okay, so it's a very slowly changing dimension. So that type of a dimension is called as a slowly changing dimension. So if a data in the dimension is changing over a period of time, then such a kind of a dimension is known as a slowly changing dimension. So we also have the second kind of a dimension, which is rapidly changing dimension. Rapidly changing dimension. It's also called as RCD. It's also called as RCD. So it's a rapidly changing dimension. So what is a rapidly changing dimension? If the data in the dimension is changing rapidly or frequently, very frequently, then such a kind of a dimension is known as a rapidly changing dimension. For example, mm, time. So time will change each and every second, minute and hour. So such type of a dimension is called as a rapidly changing dimension. So you can take the example of a time. So will the time change rapidly? For every second it changes, right? So for every minute and for every hour it changes. So it is called as a rapidly changing dimension. So we also have unchanged dimension. The third type of a dimension is unchanged dimension. Okay, so what is an unchanged dimension? If the data in the dimension is unchanged or the values are constant, then they won't change, and also they won't change at any point of time. It is called as a static or unchanged dimension. Okay, so for example, if you take a dimension called a gender, so either it's male or female, or traffic signals, so they will be either red, blue, and red, amber, and green. So they will not change, right? So all those types of dimensions are called as static or unchanged dimensions. So if the data in the dimension is unchanged over a period of time, or they're constant and they never change over a period of time, then they are called as static or unchanged dimension. Okay, so there is a other type of a dimension called shrunken dimension. Okay, shrunken dimension. So what is a shrunken dimension? The subset of one dimension is known as a shrunken dimension. Okay, so a subset of another dimension is known as a shrunken dimension. So for example, quarter is a shrunken dimension of a year, right? Month is a shrunken dimension of a quarter, and week is a shrunken dimension of a month. So if you have different hierarchies, the subset of one dimension is known as a shrunken dimension. Example, month is a shrunken dimension of a quarter. Okay. We also have the other type of a dimension called junk dimension. Okay, junk dimension. What is a junk dimension? Junk means unwanted or unrelated. So if the dimension contains unrelated information, then it is a junk dimension. So if you don't want that information at all in your database, but however it is existing, it's unwanted. So that is called as a junk dimension. So the other type of a dimension is called confirmed dimension. Confirmed dimension. Okay. So if one dimension, what is confirmed dimension? If one dimension is commonly shared by the multiple business areas, then such kind of a dimension is known as a confirmed dimension. Okay. Um, Example, uh, time is a dimension which is shared between different organizations, say college, hospital, and company. So, so basically, one dimension is being used uh, for different. For example, I mean, within a single department company, also there are multiple departments. Okay, so okay, so say XYZ is the company or ABC is the company, and it has IT, finance, HR, and sales departments. And they all work from 9 to 5 or 9 to 6, 9 a.m. to 6 p.m. So they all share a common or confirmed dimension called a time dimension, right? So if one dimension is commonly shared by multiple business areas, then such kind of a dimension is known as a confirmed dimension. Okay, so we also have another type of a dimension called degenerated dimension. Okay, degenerated dimension. So the dimension which contains only primary keys without any textual information is known as a degenerated dimension. Okay, so if a dimension contains only primary keys without any textual information is known as a degenerated dimension. So it is the only dimension table which is not having its own dimension table. Okay, so it only has a primary key. It is the only dimension table. It's the only type of a dimension table which is not having its own dimension table, which is degenerated dimension table. Okay, so for example, in this type of a dimension, you will have only a primary key. For example, if it has two two fields, so student ID and student name. Student ID will be 1 2 3 and so on. However, student name will be blank. Okay, so it doesn't have any data. So it will have only a single key, primary key. It doesn't have any textual information. Such type of a dimension is called as a degenerated dimension. So we also have a eighth type of a dimension called role playing dimension. Role playing dimension. What is a role playing dimension? So if one dimension is playing multiple roles in the fact table, or if one dimension key is attached to multiple foreign keys in the fact, then such type of a dimension is known as a role playing dimension. For example, mm, say there is a online delivery company like Flipkart or Amazon. So for any order in Amazon or Flipkart, date plays multiple roles. Okay, so date of any or on any um, order delivering app or a company will have multiple roles. for example, it will have date of order, date of service, date of shipment, date of delivery. Okay, so there will be multiple roles attached with a date field. Okay, such type of dimension is called as a role playing dimension. Here date is playing multiple roles, right? So it is a role playing dimension. So it is playing a role of an order, it's playing a role of a date of service, date of shipment, date of delivery, right? So that type of a dimension is called as a role playing dimension. Finally, we have inferred dimension. Okay, we have inferred dimension. So what is inferred dimension? The empty dimensions are known as inferred dimension. Okay, uh, what is an inferred dimension? So it doesn't have any data in it. Okay, it doesn't have any data in it. It is commonly used in ETL. Okay, as the inferred dimensions do not contain its own primary keys, we will create the artificial primary keys known as surrogate keys. Okay, so uh, these inferred dimensions will not contain any dimensions, so they will be all empty dimensions. So these are the different types of dimensions in any data warehousing. Okay, we'll see what are the types of measures. Okay, so we have three types of measures. One is additive measure. Okay, one is additive measure. What is an additive measure? So if the measure is giving us meaningful outputs after applying the aggregation. So what is an aggregation? So we have to note here that as a measure being a number. So measure is what? Measure is a number, right? So on a measure we can apply a kind of function known as a group or an aggregation. So on any measure we can apply a function known as aggregation or grouping. Okay, like one of the example is a sum or average or minimum or maximum or count distinct. So these are all the aggregations that you apply on a measure, right? So what is an additive measure? If the measure is giving us meaningful outputs after applying the aggregations with the list of all the dimensions, then it is known as a additive measure. That means mm, if the measure is giving us a meaningful output for all the dimensions. So if there are n dimensions in the table and the measure is giving meaningful outputs with all the dimensions in the table after applying the aggregation, then it is called as a additive measure. So for example, if you take sales is a measure, right? And you apply sum of sales um to the sum of sales to the sales measure, and if you analyze the list of all the dimensions in the table dimensions in the table, and all the dimensions in the table gives the meaningful output, then sales is called as a additive measure. Okay, sales is called as a additive. Basically, if you perform any aggregation on a measure and you use that measure on different dimensions, um, and if you plot a graph and it is giving, if it is giving meaningful output, then it is called as a additive measure. So the second type of a measure is known as a semi-additive measure. Okay, what is a semi-additive measure? So if the measure is giving us meaningful outputs with only few of the aggregations while analyzing the dimensions, then such kind of a measure is known as a additive measure. So for example, um, on a if there is a measure called a discount. If you take maximum or minimum and if we compare with the list of dimensions, it gives meaning outputs. Whereas if you take sum of aggregations, then if it is not giving us meaningful output with the dimensions in the table, then that type of a measure is known as a semi-additive measure. So basically, if a measure is giving us meaningful outputs with only few of the aggregations while analyzing the dimensions, then such a kind of a measure is known as a semi-additive measure. So there is one more type of a measure called as non-additive measure. Okay, non-additive measure. So if the measure is not giving us any meaningful outputs after applying the aggregations with the list of all the dimensions, then it is known as a non-additive measure. So if basically if if you do the aggregations and there is no meaningful output for the list of all the dimensions, then such a measure is known as a non-additive measure. So if you use irrational numbers like proportions or fractions, so in those cases you will not get any uh, uh, meaningful output. So such type of a measures are known as a non-additive measures, right? Um, so now these are the different types of measures and then uh, dimensions. So we'll look at fact or measure tables. Okay. So look at fact tables or measure tables. So basically a collection of measures or facts is known as a fact or measure table. So if you have a list of measures or facts, so the collection of measures or facts is known as a fact or a measure table. So based on the type of facts, facts tables are divided into three types again. Here there are based on the type of facts or type of measures. So even these fact tables are divided into three types. So the first type is cumulative fact table. Okay, the first step is cumulative fact table. What is this cumulative fact table? So if the fact table is containing only the additive facts, so if the cumulative table is containing the only additive facts, okay, then such type of a fact table is known as a cumulative fact table. So if the table, so table is nothing but a collection of measures, and if the table contains all the additive measures only, then such type of a table is called as a cumulative fact table. What is an additive measure? Additive measure gives meaningful outputs with all the aggregations in all the dimensions. So if you do the aggregations like sum, minimum, maximum, average, count um, on on a measure, and it if it gives the meaningful output of on all the dimensions, then it is called a additive measure. And if a table contains all additive measures, then that type of a table is called as a cumulative fact table. Okay, cumulative fact table. So the next type of a fact table is called snapshot fact table. Snapshot fact table. Snapshot fact table. So what is snapshot fact table? Okay. So if the fact table contains only semi-additive or non-additive facts, then such kind of a fact table is known as snapshot fact table. So if a table contains either semi-additive or non-additive measures in it, so then such type of a table is known as snapshot fact table. So it contains information, instant information like day-wise discounts, week-wise margins, etc. So which will have uh, only either semi-additive measures or non-additive measures. What are semi-additive measures? So if the aggregations give only meaningful outputs with only few of the dimensions. For example, if the output is giving meaningful output with aggregation of max and min, and not giving an output or meaningful output with sum or average, then such type of measure is called as semi-additive. And if there are no meaningful outputs even after applying the aggregations on all the dimensions, then that are called as non-additive measures. If a fact table contains either semi-additive or non-additive facts, then such type of a fact table is called as snapshot fact table. So for example of a cumulative fact table is it contains a periodic information like year-wise total sales and state-wise average revenue, etc. So these can be performed with any type of an aggregation, sales, revenue, or the examples. So discounts for snapshot table, discounts and margins are examples. Okay, so there is a third type of a table called factless fact table. Factless fact table. Factless fact table. So what is this factless fact table? In the fact table, if the fact table is containing only the keys without any facts or numeric data, then uh, such type of a table is fact table is known as a factless fact table. Okay, so if a fact table contains only the keys, okay, without any facts or numeric data, then such type of a fact table is known as a factless fact table. So these are the different types of fact tables available in any data warehouse. So now we'll look at different types of schemas. So this is a very important topic. So we'll look at different types of schemas. So what is a schema? Schema is what? So schema is a collection of arrangement of dimension tables in facts tables. Okay, in a data warehouse. Okay. So what is a schema? Schema is a collection or arrangement of dimension tables and facts tables. So there are facts tables and dimension tables, right, in a data warehouse. So schema is nothing but a collection or arrangement of these tables. So there are any data warehouse, there are three types of schemas which are available. So the first type of schema is a star schema. Okay, the first type of schema is called as a star schema. So we'll look into each type of schema. We'll first list out the types of schemas. So the second type of a schema is known as snowflake schema. Snowflake schema. The third type of a schema is a hybrid schema or mixed galaxy schema. You can see that it's a mixed or galaxy schema. Okay. So the schema can be designed using a dimensional modeling. A schema can be designed using a dimensional modeling. So what is a dimensional modeling? Dimensional modeling is the arrangement of dimensions and facts inside the data warehouse as per our requirements. Okay, what is dimensional modeling? Dimensional modeling is the arrangement of dimensions and facts tables inside the data warehouse as per our requirements. So we can design a schema using dimensional modeling. Okay, so schema is nothing but collection of dimensions and facts. So first we look at star schema now. So if all the dimension tables are directly attaching to a fact table, then such type of arrangement is known as a star schema. So we'll look that using a picture. Right. if we have a dimension table like this, say we have 4-dimension tables. And a fact table. So this is a dimension table 1. This is dimension table 2. This is a dimension table 3. And dimension table 4. And we have fact table in between. Okay. So if all the dimension tables are directly attaching to a fact table, then such kind of an arrangement is known as a star schema. So this is a star schema. So where these are all different dimension tables. So they are directly attaching to a fact table in between, right? So such type of a arrangement is known as a star schema. So this is a star schema. So we also have a snowflake schema. Right? Right. So what is a snowflake schema? So if all the dimension tables are not directly attached to the fact table, then such type of a arrangement is known as a snowflake schema. So in Snowflake, there is a direct relationship between one dimension and the other dimension. Okay. So we'll see with a picture. So these are all the dimension tables. And this is a fact table. right? So here, if all the dimension tables are not directly attached to the fact table, then such of a arrangement is known as a snowflake. So is DT1 directly attached to fact table? The dimension table 1, is it directly attached to fact table? No, right? So there's a direct relationship between one dimension and a other dimension. So there's a relationship between dimension table 1 and dimension table 2, and there is no direct relationship between dimension table 1 and fact table. So such type of a arrangement is known as a snowflake schema. So there's a third type of a schema called mixed schema, or galaxy schema. Okay, so if we combine both the star and snowflake schema, then the resultant schema is known as a mixed schema, or galaxy schema. Okay, we rarely use this schema in real time. Okay, so if you combine these both, when we have mixed schema, so we actually don't use that in real time frequently. Okay, so this is about this different dimension tables. Uh, so coming back to the Tableau desktop. So once you connect to any data source, so the data is divided into dimensions and measures automatically in Tableau. Okay, so the data is automatically divided into uh, measures and dimensions. So measures are quantitative fields, dimensions are categorical fields. Okay, so um, at times Tableau converts a dimension into measure and a measure into dimension. So onus should lie on you to convert that into a required uh, field. Okay, based upon your requirement, you can either convert a dimension into a measure or a measure into a dimension. For example, if you want to convert a dimension into a measure, so you can do that. So for example, you can convert customer ID into a measure. So you can right click on that field and click on convert to measure. Similarly, you can convert any measure into a dimension as well. Okay, so for example, you can right click on a measure and then click on convert to dimension. So you can convert a measure into a dimension as well. Okay, so there are in Tableau there are different terminologies that you need to be aware of. Okay, so in Tableau view there are different terminologies that you need to be aware of. So for that, I will open a already created workbook. So we have a window. So once you connect any database to Tableau, so we have a window called data window. So in data window, we have all these dimensions and measures. Okay, we in data window, we have all dimensions and measures along with the data connections. So in data window, we have data connections along with dimensions and measures. So what are these dimensions and measures? So in data window, we don't have complete data. So we only have a metadata, right? So this is called metadata. So what is metadata? So information about the data is known as metadata. So basically, whatever data is there in the data source, in data window, we are able to see that these are the fields which are dimensions, and these are different names of uh, the fields. So based on the names, we can identify the type of data which is residing in that particular field. So basically, so this is called as a metadata. So a data window contains metadata information about the data source. Okay, you also have analytics window here. So in analytics window, we can perform different calculations, like adding reference lines, distribution band. You can write, compute average line. Okay, so these are the different options available in analytics window. Okay, in data window we have the data connection and also the metadata. So there are some application terminologies that you need to be aware of. So this is a workbook. This is a Tableau workbook. So this complete workbook is, it's similar to Excel. So it's known as a Tableau workbook. So this is a data window. So these cards are known as view cards. So pages, marks, and columns and rows. So these are known as view cards. So if you place fields into these cards, then those will be appeared in the visualization view. So that is the reason they are called as view cards. Okay, so columns, rows, pages, and marks, these are called as view cards. Okay, and and these are also called as shelves. So within marks, these color, size, label, tooltip, detail, these are all called as shelves. So um, you can also call columns and rows as shelves here. So column is also a shelf, row is also a shelf, label is also a shelf, size is also a shelf, color, detail, and tooltip is also a shelf. We call these as shelves because you place the fields into shelves to appear in the view. So if you place a field into column, it appears as a column. So it appears as a column. If you place a field into rows, it appears as a row. So for example, product types are coffee, espresso, herbal tea, and tea. So those are appearing as rows. So the products within sub product type are appearing as each individual row. So similarly, if you are using a field in color, so they are represented in color like this. Okay, so these are called view cards and also shelves. So these are all toolbar icons. We will discuss them one by one. And the fields which are actually placed here in columns and rows are called as active fields. So the fields which are placed in columns and rows are called as active fields. So sales, product type, and product are called as active fields. So, and also, yeah. So this is a worksheet. So we have worksheet. So this is this area where we do all this analysis is called as worksheet or a view. This is called a view, or this is also called as a worksheet. Okay. So you can see that this is a worksheet. Okay, this is a worksheet, and this is a status bar. So you can see the number of items appearing in the view. So this is in the status bar. The view keeps on changing. So the numbers keeps on changing. So this is called as a status bar. So this is about the application terminology. So we will see view terminology as well. So this is a title, and these are called these are called headers. These are called headers. So these are called headers. Okay, so and this is called as a legend. This is called as a legend, and these are legend members. These are called legend members. So these are called marks. So the the views that are appearing are called marks, and this is called as a pane. So if you divide the data into subparts, those are called panes. So in product type, coffee is a pane, herbal tea is a pane, tea is a pane, espresso is a pane. So these are called panes. Okay, so you can also add a caption here. So if you want to add some note at the bottom of the view, we can add a caption here. So this is called as a caption. So also this is called as a field label. Okay, this is a field, right? So the label appears here. This is called as a field label, and this is axis. This is called axis, and these are the This is the axis label. These are the values in the axis. So this is about view terminology. So this is about view terminology. So in in view terminology, we have seen all these. So now we'll go to data terminology. So for that, we'll go to a cross tab. It's a text view, text table. So here, a field is a column in a database. Okay. So here, any field that you drag into the view is a column in a database. So a measure is called as a quantitative field. A measure is a quantitative field. Whereas a dimension is a categorical field where you can divide the data into multiple parts. Okay. So, so this is called as a table. This is called as a complete table. So each entry here is called as a cell. Each entry here is called as a cell. And if you divide this into separate parts, I mean, you have seen that there's a different panes. You can also divide these into different panes as well. Okay. In Tableau, we have an important concept called visual cues. So in Tableau, we can identify the data type by looking into some icons. So for example, ABC icon in blue, okay, this indicates that the field is a discrete field. Okay, so this field is a discrete field if it is indicated by a blue icon with a ABC preceding before it. Okay, so it's called as a discrete field. It's a discrete field. That means there are two types of fields. One is continuous field, one is a discrete field. Discrete field will have steps to it, and a continuous that means that data, if you use a discrete field, the data would be divided into parts. So whereas a continuous field, so see, so discrete field will have entries like this: North America, South America, Europe, and Asia. So discrete field will be like this. Okay. So however, continuous fields are indicated by green icons like this. Okay, green hash. So green icon indicate that the field is a continuous field. So sales is a continuous field, right? So sales, sum of sales is being taken here. So sales is a continuous field. A green hash indicates that it's a continuous field. That means it will have continuous numbers in it, numerical information in a continuous fashion. Okay, that is called as a continuous field. So if we have any field which is having a equal sign before ABC, that is icon preceded by a equal sign, that indicates that the field is a user defined calculation. Okay, if there is a equal sign before ABC, that indicates that it's a user defined calculation or a copy of another field. So you can see that here by clicking on edit. Okay, so it's a user defined calculation. Okay, if you create a calculated field, so you can create a calculated field by going into a drop down icon here, click on calculated field, um, write any dummy calculated field. So create any field like this, name it as test. See, so it's a user defined field, right? So it is preceded by a equal sign like this. So if you see a field preceded by a equal sign, then you can identify that it is a user defined calculation. Or if you even copy another field, so for example, if you duplicate, right click on the field and duplicate it, so it is also indicated by a equal sign. So it is either a duplicate of another field or it's a user defined field. At times, if you combine two data sources, so I'll try to do that. So if you combine two data sources, so there will be, at times there will be some cases where there will be unidentified fields indicated by a exclamatory mark. So in this case, we are not finding any unidentified fields. So if an red exclamatory mark is after this green hash icon, then that type of a field is called as a invalid field. So if there is no validity in the field, or for example, if you remove, okay, we'll see this. Okay, we'll actually remove a field from this. We have deleted order date, okay, and saved it on desktop. So now we are again trying to establish a connection. So now we are going to take the source, the field in on the desktop. So see that there are some unidentified fields. So you are able to see that there is a red exclamatory mark, right? So such type of a field with a red exclamatory mark icon with an exclamatory mark in red indicate that the field is a invalid field. So because order date has been deleted, right? That's why it is indicated by a red exclamatory mark, which is a invalid field. Okay. So 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 we also have a few more visual cues. So the blue color here, the blue field on a shelf indicates it's a discrete field. So blue color field in the shelf indicates a discrete field. So the green field indicates a continuous field. Okay, the field in green indicates a continuous field. We can also sort. We can also sort the data. So as you can see, there is a sort icon here. So if you see an icon like this, that indicates that it's a sorted field. It's a sorted field. It's a it's a it's a it's a it's a ascending ordered sorted field, right? So we also can perform different table calculations, which we'll see at a later point of time. So if we perform any table calculations like this, so that field will be indicated with an icon, delta icon like this. So if you see a delta icon, that indicates that a field has a table calculation. So we'll see about table calculation later. Okay, so these are the different visual cues so that we can identify the data type. So using just looking at the data, so this is all metadata, so which is describing what type of a data it is. So you can also see this icon. So this indicates that is a time field or a date field. So the all the geographical fields like postal code is a geographical field. All the geographical fields are indicated by a globe sign like this. So you can identify the data by looking at the visual cues like this. So we will discuss. So that's it for today. So we'll discuss a few more desktop environment icons and details in tomorrow's class. Do you have any questions till now?
No, I'm good, but are you going to send us the recordings later, or how the
Yes.
recordings work?
Yes. So every 2 days, I'll be sending the recordings. Okay.
Okay.
So for every 2 days. So yesterday's and today's recordings will be sent to you. So similarly, on every Thursday evening, you will be getting the Wednesday and Thursday's recordings.
Oh, okay.
Okay.
So these recordings will get into our email ID or how?
Yes. I'll either create a location where you can access from there, or I'll
Okay.
be sending you a link. So these will be
Okay,
stored in a
okay.
central location in Zoom. So I'll be sharing you the links.
Okay, yeah.
Okay. So it will be coming from my email ID itself, Kranti Kumar. Okay.
Okay.
Right. See you tomorrow, guys.
Okay, bye.
Bye.
Bye.